I'm sorry that I'm not here today to review with you, but we do still have a test tomorrow. Here are the things that you need to know. You need to be able to classify polynomials. You need to know how to add and subtract polynomials, how to multiply polynomials. Remember, we have 3 methods for that. How to factor polynomials. This includes finding the greatest common factor and factoring cubes. How to simplify radicals, and how to solve for the x-intercepts. Today you will get some review problems to complete. You will turn these in tomorrow before the test. If you have any questions about anything or you need help on any topic, today when you are in the lab, you should go to Blackboard, go to the discussion board. There's a post there called Help Desk. You can post any questions that you have in there, and I will be checking that today and getting back to you. We're going to look at a few examples just to remind you guys about the different topics we've been learning. Here, when I look at this problem, I see a plus sign here between the 2 sets of parentheses. That tells me that I just dropped the parentheses and then I combine like terms. X squared combines with x squared. I add those together, I get 7x squared. Here's a 3x. No other term has just an x, so that term doesn't have anything to combine with. I just bring it down. Here's a constant. Here's a constant. I add them together, I get 11. I have no like terms when I look through my problem. That means I've simplified as far as I can. I'm finished. Here's our second problem. In this second problem, I have a polynomial minus another polynomial. If you remember, anytime we see this minus, we're going to change it to a plus, and then every sign after it changes. Now I just drop the parentheses. And I'm going to combine like terms. Here's an x to the 4th. Here's an x to the 4th. 4x to the 4th minus 7x to the 4th will be negative 3x to the 4th. Here's an x squared. Here's another x squared. 6x squared plus 5x squared is 11x squared. You have to remember that when you're adding and subtracting, you do not change the exponents. Here we have a constant. Here's a constant. Negative 3 plus 7 equals 4. So I put a plus 4. I look through my problem. I've simplified as far as I can. I don't have any like terms to combine. Here's our next problem. In this problem, I have a polynomial multiplied by a polynomial. Since one of my polynomials only has one term, I'm going to use the distributive method. 3x times 5x squared would be 15x to the 3rd. When multiplying, we have to remember that we would add exponents together. So 3 times 5 is 15, and an x to the 1st power times an x to the 2nd power would be x to the 3rd. 3x times 7x is 21x squared. 3 times 7 is 21. X times x is x squared. 3x times 1 is just 3x. I've multiplied, so I always check to see if I have any like terms. In this problem I do not, so that tells me I'm finished. Here we're multiplying again because we don't have any subtraction or multiplying or division symbol in between our 2 polynomials. Here, because I have a binomial times a binomial, I'm going to use the full method. The f tells me to multiply the first terms together. So 3x times x would be 3x squared. The O tells me to multiply the outside terms together. 3x times 5 is 15x. The I means the inside. 4 times x is 4x. The L means the last term in each set, so 4 times 5, which is 20. This time when I look through, I have like terms here in the middle to combine. 3x squared doesn't have any like terms, so I just bring it down. 15x plus 4x is 19x. 20 doesn't have any like terms, so I just bring it down. I don't have any more like terms to combine. That tells me I'm finished with the problem. In our next two problems, we're going to be factoring out the greatest common factor. When I look through this first problem, 5x to the fourth plus 10x squared plus 20x, I look at my numbers, 5, 10, and 20. I see that the greatest common factor for those numbers would be 5. Then I check out my x's. All of these terms have an x, so I'm going to be able to factor out the x to the smallest exponent, which would be this x to the first. So this is my greatest common factor. I'm going to factor this out. So then I put a parenthesis. 5 divided by 5 would just be 1. If I have an x to the fourth and I factor out an x, I have x to the third left. Even though 5 divided by 5 was 1, I'm not going to write that in because 1x to the third is the same thing as x to the third. 10 divided by 5 is 2. If I have x squared and I factor out an x, I still have 1x. Here, when I do 20 divided by 5, I get 4. X, and I factor out an x, there's no x left to be here. So I'm finished. I've factored this problem. Now I look at my next problem. I have 3x to the fourth plus 16x to the third plus 7x squared. When I look at the numbers, the coefficients, 3, 16, and 7, they have nothing in common, so I'm not going to be able to factor out a number. So I look at my x's. I have x to the fourth, x to the third, and x squared. I will be able to factor out the x to the smallest exponent. My numbers, the coefficients, will not change because I'm not factoring out a number. All of my exponents will reduce by 2 because I am factoring out an x squared. So x to the fourth would become x squared. X to the third would just become an x to the first power, but we don't write that 1 in. And x squared, if I factor out x squared, that would give me 0, so I do not put an x here. So I have factored this problem for the greatest common factor. Now we want to review how to factor a cube. I have x to the third minus 125. This minus tells me that I am going to use this formula. Remember, we talked about these in class. You have them written down in your notes. X is already to the third power, so it would go in for a. So a to the third becomes x to the third. 125 is not to the third power, so I have to think about what times itself 3 times will be 125. And the answer is 5. So I get 5 to the third. So remember, you can use your calculator to take the cube root of 125 if you do not know the answer. So everywhere I see an A in that formula, I'm going to put an X, and everywhere I see a B, I'm going to put a 5. So A minus B would turn into X minus 5. A squared would become X squared. A times B would be 5X. And B squared would be 5 squared, but I know that 5 squared is 25, so I'm going to go ahead and write in 25. So we have factored that problem. Now we're going to practice simplifying radicals. Here I have the square root of 144. I know this is a perfect square, and you guys should too. We've been practicing perfect squares. 12 times 12 is 144, so I know the square root of 144 is 12. 45 is not a perfect square though, so I'm going to pull 45 over to the side and make a factor tree. I know 9 times 5 is 45. 5 will not go down any further because it would just be 1 and 5. 9 will go down to 3 and 3. 3 will not go any further, so I look at the end of every branch of my factor tree. I have a 3, and a 5. This tells me that I can pull out a 3. Any number that you have 2 of, you can pull one of them out. And since I only have one 5, it has to stay inside the square root. So when I simplify the square root of 45, I get 3 radical 5. Remember, we've been talking about exponent rules. How if we're adding and subtracting, exponents stay the same. If we're multiplying, we add exponents together. In this one, we want to make all exponents positive. And if you remember, if you have a negative exponent, if you move it to the other side of the fraction, it becomes positive. So x to the 6 is positive, so I'm going to leave it alone. Y has a negative exponent right now, so I'm going to move it to the bottom to make it positive. Z to the 4th is positive, so I'm going to leave it alone. A to the 5th is positive, so I'm going to leave it on the bottom because that's where it's at. B is to a negative exponent right now, so I'm going to move it up to the top. And C is to a negative exponent right now, so I'm going to move it up to the top as well. Now when I'm finished, I have all positive exponents left.